Hello, hi, and welcome to today's video. The second video about safety in our series about safety in PLCs and in automation and in TIA Portal. And this time we're going to dive in a little bit into the hardware side. The official Siemens video that I saw was like, or that I know about, is like 5 minutes long or something, and they show you just what you need to set basically every time. I will show you also some other things that I deem might be interesting, but that is why this video is mostly me just talking. I will also show one or two things, but it's mostly just talking, so sit back, relax, and stay a while and listen. Yeah, last time we have already added the safety PLC to our project, so there's not much I am going to add, except for if you go to the PLC, you now to the properties of the CPU, you can set an additional password. Like the highest level of password you can set is the fail-safe password, the F password. That is the highest level. I've talked about passwords and protection in other videos, so I won't really dive in there, but that is why we have that little yellow flag right next to passwords, to security and protection, because we can set a safety password, highest level of passwording. Yeah, so next thing is, of course, we don't really need to set anything in the PLC except for the activation. There's also some addressing, Profi safe addressing, which I'm not going to dive into because I'm also not an expert. So there's no need to change it. Then I just say I'm not going to say that, but there's no need to change the Profi safe addressing usually because that's internally for safety communication. Try not touching it. If you need to touch it, you're probably more an expert on the field. So here we go. We are going to add two modules. At first, a digital input module, and you see we only have one FDI available, and we're going to take that and just ram that in the first slot. Now I want to explain a little bit to the parameters and everything that we have got here, to the safety module, to the safety input, to the F input module, which is quite a lot. So really sit back, relax, just listen. Yeah, so this input module always has an even number of inputs because two channels basically belong together. I'll get to that. So if I zoom in, you always see two channels. You see I0.0 and I1.0, they are right next to each other, and they're basically, they belong together. Right? I'll get to that in a moment. But always consider two input channels, they belong together. Usually you have components, safety components that have two outputs, or if you look at the PLC side, two inputs. And those safety components you have to connect to two input channels in order to achieve the best result. Get to that in a second. Yeah, so if we click on the input module, we have general, there's nothing special, no yellow flag. Module parameters, nothing special, no yellow flag. And we have inputs 0 to 15, something special, yellow flag. So if I open it up, you see we have, additionally to the general and IODA addresses that every module has, F parameters and input settings. Let's look at the F parameters first. You see there is quite a lot. And that's the thing. An F CPU, every F component has many internal parameters already, many internal functions for monitoring and stuff that you usually don't need to touch because it is already set in such a way that it is safe. Of course, sometimes you need special application. You have special applications. You need to adjust it a little bit. Then you can touch them. Usually you do not. Most of these are also grayed out, as you can see, because, well, you can't change them. You shouldn't change them. Even if I do manual assignment, hey, that just changes one field here. I'm not going to go over the general F parameters here too much. I'm just going to show some that you might want to change. No, that's not too important here, I would say. Of course, for internal, just quickly explain, you see those addresses here? Those are Profi safe addresses. They are internal addresses if you want to communicate and if you're going into the diagnostics, those are the numbers that are designated for this device. So this one, if you see it in the diagnostics, has the address 65,534. It has the address 55,940 with it's a signature, and that's a ProfiSafe address 2, I assume. Yeah, and that is just in the diagnostics, you will know that it's this device, basically, very roughly. Then we have, those are more important, the behavior after a channel fault. So if one channel has an error, right, if there's something wrong with one channel, like a timeout error or a short circuit or anything, you can choose to passivate the channel, which will still make the channel available. It's still being monitored, but it is not actively doing anything. You're passivating the channel, or you could passivate the entire module, which means if there's one error, everything else will also recognize that and will not shut down per se, but passivate, meaning just deactivating for the moment. You have to activate it again, basically. Yeah, exactly. And this making it active again is the reintegration. So if there is an error, you have to reintegrate you can set it to all channels manually, which would mean you have to go through all channels manually, all channels automatically, which then happens automatically. So you don't have to reintegrate all channels. It's done automatically internally, or you can make it adjustable, which is a mixture of, hey, I want 10 channels, that should be automatically, 4 channels there, it shouldn't be, stuff like that, or 6 channels. Usually you want that to manually to have the highest control. And that's what it's set from the beginning on. Yeah. And the rest down here is just some parameters. You can't even adjust it. Those are just informations for you. Important, well, not important, but nice to know is the lower 2 here, the DB numbers and the DB names. This module that we have generated, it comes with internal diagnostics, it comes with a lot of information, and we can of course access that information. If I go to my program blocks, there we have, as soon as we've got a safety program, we'll talk about that next time, we have safety blocks, step 7 safety, and there is failsafe IO data blocks. I have one module, it's this one, this is my IO module, and this one, the IO DB name is this F000, FDI16, and so on and so on. So it's exactly this. If I want to check out this one module, I can just open this data block, and once we have downloaded the program, I can just go online and I can see all the things that are going on. For example, is the passivation right now on? Yeah, it is. Then there's going to be a 1 in here. So you have some things that you can read back, and you can also have some things that you can output, meaning those will do something if you activate them in your program, and those are just for your information. Right? And we will have one of these modules, one of these data blocks for every safety IO that we will add. So I can also add the second one here, and you will see a second data block is being generated just for that digital output module. Okay? And those are 2 separate ones. So there's diagnostics and configurations for every single module. Yeah. That's this. Yeah, those are the F parameters for the total module. Usually you don't touch them. What I'm saying, usually you do not touch them. What you do touch is the single channels, right? As I already said, you have these 2, they together can be used as one channel. These 2, they together can be used as one channel. These 2, one channel, and so on and so on. Therefore, we have to go to inputs, right? Inputs, and you see sensor supply and channel parameter. Depending on the PLC you're using, I think the 1200, the sensor supply is not listed extra here, might be. Let's quickly talk about the sensor supply. The sensor supply is basically, does the sensor come with its own power supply already, an info supply, or do you want to have that through the PLC? You can set that for different channels differently. You see here, sensor supply 0 is from channel 0 to 3. 0 to 3 is, this is 0, this is channel 1, this is channel 2, this is channel 3. So all of these 4 right now have the same supply. You can theoretically deactivate it if you want, which is not recommended, depending on the sensors you have, of course, but usually you don't do that. Yeah. If you have it active, you can have a short circuit test, which monitors these 4 channels now if there's a short circuit. That is recommended to have it on, so you know if the channel has been short circuited or not. There is time settings. You can say, hey, if there's a short circuit, how long is the short circuit, like time-wise? 4.2 milliseconds, that's already quite long. That's fine. Usually you don't touch it. You might activate the short circuit test, but usually you don't touch the timings. What you could do here is you can set all channels. Right now we have the first 4 channels. They have their own supply. We have the sensor supply too. It's channels 4 through 7. That's the 4 on the bottom here. You have, hey, make a guess, the 4 on the top right, 8 through 11, and we have, of course, 12 to 15. That's the bottom 4, the bottom right 4. You can also set all of them to one sensor supply if you want. Now they all have the same sensor supply. Because I selected, hey, channels 0 through 15, they have the same supply. Sure, why not? Recommendation is, of course, all of these have their own sensor supply. That makes the most sense in our case, and they all have the short circuit detection activated. Here we go. So usually you don't tinker around with those settings. What you might activate is the short circuit test. That's the standard. Now the important parts, the channel parameters. There you see we always have channel 0 and 8 is combined, channel 1 and 9, channel 2 and 10, and so on. Channel 0 and 8 is, this is channel 0, this is channel 8. This is channel 1, this is channel 9, and so on. So they are always paired, also from how it looks like here. So if I go to the channel parameters here, I just selected 0 and 8. So that's this one here and this one. The standard setting for all of them is a sensor evaluation 1 out of 2 evaluation equivalents. That means that input 0.0, I should draw a picture maybe. Yeah, wait, I can draw a picture. Let's quickly draw a picture. That means a sensor evaluation 1 out of 2 means that you have somewhere a sensor. Let's see, yeah, red. You have somewhere a sensor. That is a sensor. Yes, it is. Very pretty. This sensor is a safety sensor. It has 2 outputs. The sensor, 1 output would be connected here, and 1 output would be connected here. Right? Why 2? Because of, well, redundancy, first of all, and that is what the safety is built on. A lot of redundancy. You want to see if one of them already fails. It could be that one of them is stuck in a door, for example, or someone steps on it, or someone bent it, or it's just a wire break, or one of them heats up too much. That also slows down the communication, or one of them is too long or too short. Stuff like this, it's all being monitored. So for example, if this one breaks, right, then we will have an error on both channels together. That means 1 out of 2. Right? 1 out of 2 means we're monitoring both channels here, both channels at the same time. And if there is this discrepancy, that's what we call a discrepancy. Now this signal here would be a 0, for example, and this signal would be a 1 because the sensor is sending out something. That is a discrepancy, and that leads to errors. What's wrong with my camera here? It doesn't matter. If I'm not sharp anymore, fine. Yeah, so you can set that. Right now, we would have this discrepancy, so the channel would analyze it and your safety program would directly react on it. What does directly react on it mean? It's the following here. Directly react on it is, first of all, we have to set a so-called discrepancy time. Because sensors and wire breaks, well, they take some time. And usually you don't want to react immediately because there's sometimes bouncing, there's sometimes some fields. So you want to usually have that a little bit higher, the discrepancy time, in order to give the sensor some time to actually react on it. Right? So 50 or 100 milliseconds is pretty standard there. Yeah, that's the discrepancy time. And then we have the second is the discrepancy behavior. If you have if you are detecting a discrepancy, the standard setting is that you are, after the discrepancy has been detected, so after 50 milliseconds, if those signals are different for 50 milliseconds, you will supply a value 0. So you will have a result out of the evaluation of your safety, out of your safety channels here. It will supply a 0. You could set that to supply the last valid value, which would basically, if there's an error, just send the signal that you last had. Of course, there's some applications, but usually you want to supply a 0 to really analyze, hey, there has been an error, this is wrong, there's been a discrepancy. Yeah, so that's the 1 out of 2 evaluation, right? There's also a 1 out of 2 evaluation non-equivalent. There's sensors. So can I just go back here? No, I can't. Oh. So there is this sensor, for example, that we had that usually sends out a 1 on both if it's fine, or a 0 on both, depending on the signal, right? A 1 or a 0, but always the same signal. Those sensors exist. There's also sensors that send a non-equivalent. A non-equivalent would mean it sends on one a 0 and on the other one a 1. So that you know, hey, if the signal is different, that means it's okay. So they are always the opposite, right? So that's the that is the non-equivalent here. So you just need to know what your sensors are, what your safety circuits are made of, right? Yeah. And there is the last, would be 1 out of 1 evaluation, where your sensor just has 1 output, right? Or it just has 1 output, it sends a 0 or a 1 depending on the sensor state, but just 1 output, which is for safety usually not the best. You should have the 1 out of 2 evaluation, highly depending on your application, of course. Yeah. Last here, this is so much talking. I am so sorry, I'm talking so much. This video must be so boring, but well, welcome to safety. Next here is the reintegration after discrepancy error. So if we detect over 50 milliseconds, if there is a discrepancy error, so if they're different, if we have an equivalent value, so 1 is 0, 1 is 1, after 50 milliseconds, the module will detect, it will go into error state, and you will have to fix it. And this says, this one here, the reintegration after discrepancy error, is just, do you need to check if you fixed it, or is it okay if they just go on at some point in time? If you say test 0 signal has to be necessary, both channels have to be 0 to be able to reset the module. Right? You have to go through the 0 cycle to actually tell the module, hey, everything is fine again. So that would add some additional safety. Usually you need that. You don't activate that because usually the sensor itself does something like that, because you're using special hardware also on the sensor side. Good. So that's fine. So much talking. I'm sorry. Yeah. Then we have the channel parameters themselves, right? I have channel, do I have 1 out of 2? Yeah. We have the channel 0 and channel 8. You see they are both under this point, so we can just check out the parameters. We can deactivate the channels, which you usually don't do. If I deactivate a channel, of course, we can only do the 1 out of 1 evaluation, which we don't want right now. We want this. Yeah. There we have an input delay. So if your sensors are very, 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 very fast, you can go down with the delay. You usually don't. 3.2 milliseconds should be fine. Yeah. Then we have this channel failure acknowledgement, which I said earlier you have set in here. You have set somewhere, you can set it to manual, I think. I forgot where it is. But we keep that to manual. You will see later in the next video about the software, about the program, how to acknowledge those channel failures. But we set it to manual earlier. You saw it in the video. And the last thing you can set for every channel is the chatter monitoring, which I cannot activate right now. The chatter monitoring is only available if you go 1-on-1 evaluation. Then we have the so-called chatter monitoring. Chatter monitoring is some sensors, or there could be signals annoying your sensor, and your sensor usually sends a straight 1 or a straight 0. What could happen is, if you have a bad sensor, if a bad push button, you press the push button and the signal doesn't go from 0 to 1 right away. It just goes 0, 1, 0, 1, 0, 1, 0, 1. It bounces. It bounces on and off, on and off, on and off. And if your input module detects, in this case, 5 bounces in 2 seconds, so 5 times on and off in 2 seconds, or if you're opening, closing the door very fast, if it's a safety door with a safety sensor, or hitting e-stop 5 times in 2 seconds and unlatching it, then this module would give you an error. Right? So chatter monitoring makes sense to adjust. You can also adjust, hey, 5 times, that's way too less. I want 50 times in 2 seconds. Maybe 50 is too much. I want 15 times in 2 seconds. You can change these. Only available on one channel, because if you have 1 out of 2 evaluation, well then if one of these bounces, one of the outputs, right? If one of them chatters, then you would have a discrepancy anyway. So you don't need that chatter monitoring. Yeah, so that's chatter monitoring. You see there is a lot to consider here. Usually you don't change anything. You just change the method depending on your sensors, right? And of course you can check that for every channel pair. So now I have channel 0 and 8, it's 1 out of 2, so they both go together. Channel 1 and 9 is now 1 out of 1, so they both are individual, depending on your sensors. Good. So much for this input module, 20 minutes. I'm so sorry. Let's go on. For the output module that I have added, we also have the same F parameters that we can set here in there. So it's the same as we had with the input module, so not going to talk about this. And we have the outputs that we can set here. And then we can set some switching mode, some test periods, right? You have testing periods. You are testing your outputs. You don't need to do that. That's one advantage of the safety modules. They are constantly testing if the output connected to it, if the output module itself is okay, and if the output connected to it, like there could be a drive connected to it or a relay or whatever, it permanently monitors if that is okay. You see this one here has a test period of 1000 seconds, for example. So every 1000 seconds, the output is going to be tested, whatever is connected there. There are different modes. There's 2 different modes. I'm not going to get into them. One is monitoring against another output, and one is monitoring, so you also have output pairs then basically, and one is monitoring against ground. Doesn't really matter, not going into details with this. If you need details of this, just hover on top of it, click here. Wait, that didn't work. Just hover on top of here. I'll show, wait. Up on top of here, and there you can go into the settings, into the help function, read about it. This is another whole topic. You need to study basically to understand it. That's the general operating mode. So you're testing, done. You're testing all your outputs, and now every single channel you can adjust separately what you want to test. Wire break diagnostic makes sense, but only activate that if you connect something to the output. If you don't connect anything to the output and you have wire break activated, you will have a permanent error on it because it seems like the output is permanently cut off. So yeah. So right now, let's assume I've got something connected to channel 0, but nothing anywhere else. I could also turn off all the other channels, right? That's probably even better. Not mandatory, but it would be better to do it if you're not using them. But then you must not forget about it. Good. Yeah, channel failure acknowledgement. Again, we have set the global one to manually for every channel, so it's manual again. And then we have so-called monitoring parameters. And this is a complex topic on its own. I recommend not changing anything. There is testing going on. If you hover on top of here and you go there, and there you have information, the information system is going to pop up, and I'm just going to quickly show it to you. It is rather complex. There's testing going on, right? There's this whole thing here going on. What is basically happening? What was it set to? Every 1000 seconds, the channel here, or every channel that is active, is being tested by your PLC. Being tested means it's being turned on and off very quick, so you don't even realize it's happening, but it is still happening, right? It's still happening, and then you have a readbacks. the channel is actually analyzing what is connected to the output. So it's turning off and on the output, or on and off, depending on the state. And then the output should not react in that time because it's just happening so fast. If the output still reacts, that means something is wrong with the hardware connected to it. And that would give you an error and you can analyze it. So yeah, that's what you can set here. I recommend not changing anything because that's automatically monitoring if there's something wrong. However, if you have cheap components connected to this, or if you have old components or whatever connected to this, you might need to change those values here. Right? You might need to change them depending on your output module, on your hardware that is connected to it. But I recommend not changing them if you don't need to. Good. So that's the output module, almost half an hour. This video is way too freaking long. I am so sorry. Last thing on this, right? Last thing on this is now that we have set everything here, we can also, if I go to my input module, there is IO tags, right? There is IO tags, and for my channel 0 and 8, I have set 1 out of 2 evaluation. So channel 0 and 8, they go together. And in the IO tags, it is not shown. It is not shown in here. I can give it now a name. This is, for example, an e-stop. Right? And you see it's not really shown here, unfortunately. I could also write e-stop here. Right? Now it's e-stop 1. So they are still shown as the same thing, as different things, but they are not. Right now, because I have set these two to 1 out of 2 evaluation, the second one here doesn't do anything. Always the lower channel is responsible for both. So this one, if I use this in my program, I will have many errors because it doesn't do anything. So get rid of this. A 1 out of 2 evaluation means both of them work together on the lower channel. So in our case, I00. Right? This one is responsible for both of them. If I have 1 out of 1 evaluation, right? If I have 1 out of 1 evaluation, like channel 1 and 9 here, of course they both, this is channel 1, hey, there's something connected to it. Channel 1 and channel 9, hey, not connected. They both work separately. So now that is okay. They both work separately. Of course, it's not this one, it's this one. Whoops, I'm bad. This one here. They both work separately. Right? So this one and this one, they are separated. Not like this one and this one. Both of these are together inside of this. Good. The very last thing, oh my goodness. The very last thing is if I go to my safety administration here. One important thing about safety is standardization, and that you can see what was changed, not what was changed, but if something was changed. Now I have made some adjustments. If I now compile, I first want to check if everything is okay. Everything is okay. We have so-called signatures. You see these? Those are signatures telling us like a state. This is the state. Right now we have this state. So I can save these numbers. It would be the best to save all of these numbers. Right? Right now we're talking about the hardware signature. It's this one. Whoops. And you see it is just a number. Save the number somewhere because it is important. Because for safety, you want to know if something changed. If something has changed in your safety, that means it is maybe not okay with the contract anymore. Because the contract was made, or with your internal documentation or whatever. Because if something was changed, it's not guaranteed anymore that it worked. It works with the tested state. So if I now, for example, change anything in my hardware here, let's get rid of this IO module. You will see in my safety administration, the numbers are gone again. I can recompile. And after recompilation, you will see that our hardware signature here is different now. There it is. It used to be 084 something, and now it is 133 something. So we know something was changed. So it's best, this is very important for safety to know, hey, nothing has changed. No one has tinkered with it. We can still see the signature for the software is still the same, right? It's exactly the same now. We haven't changed any software. The collective signature for everything has changed, so because we changed the hardware. Very important values, always write these down, always save them. Good, I think half an hour is enough to talk about the hardware here. I'm still in preparation for the next video. I'm still gonna crank in the output module here again. I will not add any IO tags or something to it. I will delete, just in preparation for the next video, I will delete the IO tags that I have created on it, so we can start fresh for programming. In the next video, we're gonna go into programming. This was way too long, sorry for it, but I think important topic and a lot of information's in it. If you want to read about it, there's of course online guidances, but I always recommend the information system that Siemens has integrated into your portal. Go in there, read about it. Perfect, perfect self-learning, autodidactic learning. Good, great. That was way too much talking. If you have any questions, leave a comment below. If this was great, leave a comment below. If this was awful, leave a comment below. Check out the forum, link is in the description below. And also, if this is any helpful, consider tossing some coin in my direction, like 60 people already did. Thanks, Thomas. Thanks, Patrick. I think I thank you already. Awesome. Thank you. This goes directly to me. That would be great, supporting me, because there's a lot of effort creating these videos. Good. Enough about this. Next time, we're going to get on with safety programming. We're going to start creating a program here, program blocks. Good. Don't forget to like, don't forget to subscribe. I'll see you in the next video, and stay safe and healthy. Bye-bye.